or how it comes into play at all with the question. Just a little confused there myself. So with has-a relationships, right, you could actually represent each of these different type of dice with a single class, and you wouldn't have to really change anything except like the constructor accepts an argument, the number of sides, right? And then you could roll a number between 1 and the number of sides, right? So write one class, it's solved. So you wouldn't have to write different classes for each one. The potential downside of this would be that if you wanted to have some kind of special dice where each of the sides wasn't equally likely to happen, it would be a little bit more difficult to implement. So maybe what we should do is we should go with both options. So we could have a die subclass, like a die parent class, and still have that abstract method role on it, the virtual method role. And then you could have like a, normal dice or a equally sided dice, right? And then you could implement, they could inherit from the die class, and you could implement all of your possible, D4, D8, D6, D12s, D20s inside that one class, because they each are, equally likely, they just have a different number of sides, right? And then if you wanted to have some special magic die that does something else, you could still inherit from the base class to do your magic differently weighted sided dice. Does that make sense? Right? Another example of this kind of question is, how many of you guys ever played Pokemon? Right? So think about Pokemon. Pokemon have types, right? But you might also say something like Charmander is a fire type Pokemon, or Weedle is a insect type Pokemon. So should we use has a relationship to represent types here, or should we use is a relationship, right? A Pokemon is some particular type of Pokemon, or a Pokemon has a type. Has a type, is a type. So think about what your trade-offs might be if you decide to go with one option versus the other, right? If we use is a relationship, what happens if a Pokemon is multiple types of Pokemon? They are a fire and a water type, or a ground and a earth or grass type, right? That might make things a little bit more complicated because you might be inheriting multiple data members like we saw before with our professor class that was inheriting a name from both the researcher and the instructor, right? So has a relationship would make it a little bit easier, I think, in that particular context to represent it, because you could just have a vector of types, right? The is a relationship might make your code look a little bit cleaner, like when you're doing like the damage calculations and you're determining like type weaknesses or type strengths. So it's just things to think about, because language can be a little bit ambiguous when you can say something can sometimes have something or something can sometimes be something. Be really careful and be considerate of what the design trade-offs are going to be of going one route versus the other, or maybe there needs to be some combination of the two. Does that make sense? Okay, so as I promised, we're going to pick up from where we're going to implement AI players in our tic-tac-toe game. So the first thing that I'm going to do is I'm going to create a new branch so I don't jack up all my old stuff. I can go back to it if I ever need to. So you might say, with AI. So the first thing that we're going to need to do is work with our players, right? Because we're going to have different types of players. We can now have a human player and we can have an AI player, but both human players and AI players are players. So first thing I'm going to do is I'm going to rename my human player class into from that's just player to human player. Okay, and yeah, Shift F6 or right-click, refactor, rename. Or again, right-click, refactor, rename. You can see the shortcuts right there, Shift F6. You can also change the signature of functions using change signature control F6. You can also extract some section of code into a parameter or a method or a superclass. So we will make a new class right here. It's going to be player. Add to targets. Players or a human can play an AI, right? So here I think we called our namespace So the first thing that we should do from wherever human player is at is we should figure out which of these things are consistent among both humans and AIs. So what things are a part of all players? So do all players have a name? Yeah, probably. Do all players have a piece? Yeah, we should also probably have like get name and get piece. Should also probably be a part of it. So we're going to take all this stuff and we're going to move it up into the player. And then this guy is going to change to what protection level so that our children can access it. Protected. And we need to include string here. And we're also going to make these methods virtual in case anybody needs to override what they do. So our children can now override it. Name. And then return piece. We will also now generate a constructor, but we'll have CLine do that for us. That takes in both pieces of information. And then we might also need one that does nothing right now. Okay, so we have this stuff implemented, and we're going to go into human player, and we're going to get rid of these things. Should we have anything else defined on a player besides the ability to get their name and to get a piece? Yes. We could put a destructor in here, but like our destructor is not going to do anything because we don't have any dynamically allocated space, so we don't need to delete anything. But sometimes it will complain at us if we don't have it. So, yeah. There. But anything else we want generic players to be able to do? Yeah. So have a turn or be able to get a move, right? Because how we're going to get a move is going to be different dependent on whether we're a human player, right? Or we're an AI player. What we do is going to be very different. So we do need a get move. And so over here, I'm going to forward declare move. How do I do a forward declaration of move? Last move, right? And then down here, we're going to have a virtual method to return a move, get move. Shouldn't change us at all. And what should we do in this method just for a generic player? Do we know what to do for just a generic player and how to get a move? Probably not, right? So how can we say that we as a parent are not going to provide an implementation for this method? Just equals 0, right? This makes this method what? Pure virtual method, right? It's not implementation. And what does this make our class now? Abstract class, right? Because we have at least one pure virtual method. Does this make sense? Okay. So now we might pop back over here just for a moment to tic-tac-toe. And since we're going to have different types of players, right? Can we have a vector of just human players now? No. What do we need a vector of? Can we have a vector of player? We can't have a vector of players. Why? Yeah, we can't make an instance of the class because it's abstract. Also, we couldn't just make an, even if the class wasn't abstract, we also could not just do a vector of player, right? Because we need to be able to put different types of players into this vector. Human players as well as AI players, right? So this class needs to change. And I'm going to, I guess technically, probably get rid of this. Maybe. So I should have a vector of, we can have player pointers, but what would be better than just having player pointers? Unique pointers to player, right? So std : unique pointer to player, right? Why is it better to use smart pointers here as opposed to dumb pointers? Well, it's better to use smart pointers here because when the vector gets deleted, what's it do with its elements? It destroys them. So when it destroys the smart pointers will destroy what they point to. If we just use normal pointers, we would have to, in our destructor, go through each element of the vector and then call delete on it, and then allow the vector to be deleted itself. So this saves us from forgetting to deallocate memory. Okay, so that's going to need to change, and we're going to change some other stuff later on. Or maybe we should start up here. So the first thing is we can't do this anymore because we have to have different types of players. So we're going to start with no players, right? And then maybe what we now need to do inside here is after we create our empty vector, we might now need to say something like add players to game. And we'll add 2 players to our game, right? And so we're now going to allow the user to ask, like, hey, do you want an AI player or do you want a human player? And then we're going to go and add them to the game. So this method should be private. And we might have void add players game. I called it. No consistency, Matthew. Oh. No. Oh, I know what the problem is. I haven't finished doing this class. Not const. And some things are going to need to be changed because we have pointers now as opposed to, or actually, this will actually be a little bit easier now. What should we do in this function now? Because players at player turn is a pointer to a player, but I actually want to get the player itself, so what do I do? Reference it. This complaint is, okay, yeah, this signature needs to change. And then this one also need to change its type to be player. Okay, that's good. Okay, so what should we do over here? Well, we have a for loop for I equals 0, I less than the number of players. What should we do? Again, like at this point in time, we want to, for each player in the game, we want to ask whether that person is supposed to be a human player or an AI player. So let's say like 1 means human player, 2 means AI player. What do we do? Yeah, you ask. And we're going to be lazy. We're not going to do any input validation right now. We can come back and add that in. It's just going to take a bit of time to make that happen. So we might have something like int player type. Then over here we might have like const int human player equals 1, AI player equals 2. So want one for human and 2 for AI. Okay. So I have the type of the player that I want. So what should we do if the player type is equal to human player? Construct the human player and then add them back to the vector. So we would do something like players dot push back, and we want to push back. How do we make a player? Make unique, right? Because we're trying to make a unique pointer to a player. What type of player do we want to make? Human player. And I think we need to include human player up here. Human player, and then we need to pass in whatever their arguments are supposed to be, right? And then otherwise we should I might need to do this. No. We'll figure out what the complaint is for that in a minute. Oh, because we haven't made an AI player yet, have we? One thing we forgot with human player was human player should do what with normal player? Yeah. So how do I inherit from player? Public player. Right, now our human player is a player. And then I think if we go back here to TicTacToe.cpp, it'll stop complaining about here. Because now we've inherited from a player, so a human player is a player. And we also need to go make an AI player quickly. AI player. That looks right. Need to pound include player dot h, and we need to inherit from our parent, which is player here as well. And now back here, and we pound include AI player, make unique AI player. And again, if they have arguments, we're going to need to make sure to pass those arguments into that class, whatever we need to do to construct it. Does this make sense so far? Okay, any questions? Okay, so now we need to go back up here and change this. This needs to be moved somewhere else. So sure, get valid move. Maybe they should probably be changed to get current player move. So what should we do in get current player move? Just to comment this out for right now. What should I do in get player move? Return get current player dot get move. Fantastic. Right? We'll just ask the current player for their move, whatever they happen to be. So we're going to do the human player's get move first because we've more or less already done that. Yeah. I don't remember. So here, like one thing that you can do if you want to, you can do code override functions, and then you can select which one you want to implement. So get move, and then it's going to go and cause us to inherit from our player, and it'll go create the definition. So back over here from TicTacToe, this is more or less what getting the current player's move was. So we're going to move this back to human player, and we're going to see how things change. This is oh. Okay, so we are the current player, so we don't need this. But we might have so we are the current player. We are the move maker. And then we might say, you know, enter the row and column that you want to play in, right? All this stuff should more or less be the exact same thing that we had before. We might need string stream now. But notice over here we needed a board. So we might need to pass in some more information to this function, right? Agreed? So we might change the signature of this function. I do want to refactor the base function. So we need to add a new method or a new member or a new argument to this function. What's it need to be? What information do you need? What information do you need to know in order to get a move? Board reference, right? So just board reference. Are we going to change the board in getting our move? So it should be const. We actually won't be changing, excuse me, the board because in getting the move. We just in getting the move. When we make the move, yeah, the state of the game will change then, but not in just obtaining what move we want from the user. We might call this one board. So now we refactor. This seems good, right? And then our constructor pretty much still does what it was doing before. And so we don't need any extra arguments in order to make our constructor for the human player happen, right? Now, the next thing that we need to do is for our AI player, well, we're going to need to implement his getMove method. So code override functions, getMove. So how should we journey to board. Oof, okay. So what should we do in order to get an AI's move? What could be a possible technique? We could randomly pick, right? We could have it just horizontally scan across and pick the next empty space. We could have it scan vertically or do any number of different things, right? And we could have different types of AIs if we wanted, right? But for us, we'll just randomly pick a move. So how are we going to make the random move picking happen? So we could create an array of the available cells and then randomly pick one from among there. That sounds like a good idea. So the first thing that we're going to need to do is construct, right, the random moves, and then we'll go and we'll pick one. So how can I go and construct the random moves? Again, we have a board. It's over here. And back here, we have like an at method that would give us the piece at that position. So over here, oops, back here. Oh, come on. There. So we have this variable like, potential moves. And what should the type of potential moves be? Pointer to, that's not really going to work so well, right? Because we have to give back at the end of the day a move, right? So we could have what? We could have a vector of moves, right? It seems like it would make sense. We need to make sure that move supports this. Yeah, move would support this. So I need to include vector. So I have an std : vector of move called potential moves. And how am I going to generate these moves? Yeah, we have to iterate through the positions. So how can I go through the positions? Yeah, for loop. So for I equals 0, I less than, or maybe we'll change this name, be something a little bit nicer. For row is equal to 0, row is less than board dot size, right? We also have iterators over our board, so we could have used those too. For call equals, but we need the position, so probably not. Board dot get size. If, right, board dot is blank space, row call. What should we do? Push it to the back, but we're actually going to use in place back. So potential moves dot in place back. This will be a little bit faster. And then we need to pass in the arguments to a move. Well, a move needs a maker, right? To start this. And we might also probably want to do something like this where I can pass in like the row and the column and myself. But this is not going to cause us to go back over here, and we're going to need a new constructor. So code generate constructor. And this one actually needs to change this signature here. Should be oops. This should now be just a player reference, right? Give it a second, it'll get there. I think. Okay, there it goes. I guess we still also, no, this should be now. As well, player. I think everything in move should still otherwise be fine. But now, instead of including human player, we just include player. Okay. So our new constructor, code generate constructor. We are passing in the maker row column, and I'm passing this one too. So we just initialize everything. Because of how we had stuff set up before, probably a little bit bad. Because of the parse input, right? That was like really tied to it being like human players. So we should probably move this out of move. Agreed? Right? This should be placed into our human player. Agreed? We're going to take this. This now can just be this. And then bye. Went away. So over here in human player in get move, we should have something like or maybe this should just be something like sorry. So do this. Wait, did I not put that stuff inside this class? Okay, so we assume that we, assume all is good, right? Enter the row and call me on a plan. We get it while not parsed successfully. This curly bracket should be here. Okay, so this looks like what we should do, something like this. Oh. And then this needs to take in now. They're gone. This goes away. Oh, this is fine. So now we need 2 more functions over here. Row. Okay, so like the issue that's going on here is that we need to be able to like use this variable in this reference, which means it has to be created outside of this curly brackets to be referenced outside here. Otherwise, it would be deleted. So some things got a little bit more complicated. I need to go back and provide some const versions as well. But okay, back here in our human player, we're not returning anything anymore. So things should be happy, right? First thing is to input into our move. While it's still valid, while it's not valid, we keep asking again to get that information. So back over here in AI player, where this all kind of set out. So now we just have row call. But I think move, I need to change this signature to not have this variable anymore. We don't need it. It's gone now. Also, this function is gone too. He's gone too. Okay. So we made our move and we added it to the back of our list of things. But if we think about this part right here, this kind of seems like a single step, right? A function. So again, like one thing that you can do is you can highlight this code, right click, say Refactor Extract-Method, and it will go turn it into a function for you. I know, right? So our return type over here should be a std : vector of move. And it might be called like generate possible moves. And then we say, I think actually I want to do this here. Oops. Okay. Apparently it needs all of this. Alt-M. Return type is an std : vector of move. I'll generate possible moves. Extract. I guess just should be like TicTacToe Game move. Did it not throw one into the... I thought it was going to. Put it in the header file too, but it didn't. It goes down here. And this goes away, and this goes away. And that goes away. Okay, all is happy in the world. So now we have this function, and this function can return the potential moves. And then we might have something like auto potential moves is equal to generate potential moves, generate possible moves. And then we need to randomly pick one, which we'll do on Monday. It shouldn't take us more than a couple of minutes to make that random generation happen. We probably also now need to have like random number generators either statically shared across all instances of the AIs, or each AI is going to need its own random number generator. But we're almost done with this. And then on Monday, we'll also get into exceptions too. And if we finish that, we'll be done with C++. And then we'll be able to move into C.